Hey everyone, and thanks so much for tuning in. Today, we're going to tackle a huge concept in Python, object-oriented programming, or OOP. Now, I know it can sound a little intimidating, but my goal here is super simple, to take this from confusing and, well, abstract, and make it totally clear. We're going to see how it helps us write way better, more organized code. Okay, let's just dive right in. So, first things first, why do we even need OOP? Let's start with a really common problem. Imagine you want to represent a software engineer in your code. You could use a list, right, like we see on the left, but you can probably already see the issues. What's the third item again? Is it their level or their salary? What if you forget the age? It gets messy really fast, and it's super easy to make mistakes. You don't have an engineer, you just have a jumble of data.
And that really leads us to the core question that OOP was invented to solve. How do we take all that related data, the name, the age, the level, and package it up neatly with the things an engineer can do? How do we put it all in one logical, clean container?
Well, the answer is object-oriented programming. And it all boils down to two really simple, powerful ideas that work together. The idea of a blueprint and the actual thing you build from that blueprint.
First step is the class. And honestly, the best way to think of a class is as a blueprint. If you're building a house, the blueprint describes what every house should have, right? It's got rooms, windows, a door. But the blueprint itself isn't a house you can live in. It's just the plan. A class is exactly that for our code. It defines the structure, but it doesn't hold any actual data itself.
So, if the class is the blueprint, then an object is the actual house. It's a real, concrete thing that you built using that blueprint. And here's the cool part. You can use that one blueprint to build a whole neighborhood of houses, and each one is its own unique object. They might have different addresses, different paint colors, but they all came from the same plan.
So how does this actually look in Python? Well, every class has this special setup method called __ in init. You can think of this as the constructor. It's the bit of code that runs automatically whenever you create a new object. And see that word self? That's just a way of saying the specific individual object we are creating right now. It's how we attach the data, like the make and model, to that one particular car.
And this is where it all clicks into place. Using our single car class, our one blueprint, we can stamp out as many individual car objects as we want. See? We've got car 1 and car 2. They were both made from the car class, but they're totally separate. They hold their own unique data. One's a Toyota, one's a Honda. This is the heart of what makes OOP so organized.
Okay, that's pretty cool. But what if we want to create a more specialized kind of car, say an electric car? Do we have to start all over and write a new blueprint from scratch? Nope. And this is where we get into the real magic of OOP, with a concept called inheritance.
We can do this using inheritance. We can create a new electric car class that is a child of the original car class. And to do this without repeating ourselves, we use that awesome little function called super. That line basically says, hey, run the original car class's setup to handle the make, model, and year for me. Then, all we have to do is add the new stuff that's unique to an electric car, like its battery size. It's all about not reinventing the wheel.
So here's the takeaway. Inheritance lets us build a kind of family tree for our code. You start with a general parent class, the main blueprint. Then you create more specific child classes that get all the parent's features for free. From there, you can reuse what you need, you can extend it with new features, and you can even override old features to make them behave differently. It's just a fantastic way to keep your code dry. Don't repeat yourself.
Okay, this is all great in theory, but where does this stuff actually show up? Let's talk about why this all really matters when you're writing real code.
One of the biggest benefits is a fancy-sounding concept called polymorphism. It literally just means many forms. And what it means for us is this. Since an electric car is a type of car, we can treat them the same way in our code. Imagine you have a function called refuel. If you call it on a regular car object, it adds gas. But if you call that exact same function on an electric car object, it could recharge the battery. Same action, different behaviors. This makes your code incredibly flexible.
And trust me, you will find these OOP ideas absolutely everywhere in Python. All the big web frameworks like Django and Flask, game development libraries like Pygame, even powerful data science tools like Pandas, they are all built on a foundation of classes and objects. To really master these tools, you've got to understand OOP.
So if you take just one thing away today, please let it be this. The whole point of OOP, the big reason it exists, is to help us manage complexity.
As your programs get bigger and bigger, organizing your code into these neat, logical, and reusable little bundles isn't just nice. It becomes absolutely essential for building software that you can actually maintain and grow over time.
So that brings me to a final thought for you. Just look around you right now. What's a real-world object that you could model with a class? A book? A coffee mug? A user on a website? Thinking in this way is the real first step to mastering OOP. Hey, if you found this helpful, please consider subscribing to the channel. It honestly gives me all the motivation and energy I need to make more of these explainers for you. Thanks for watching.